Hi everyone. Today in this video session we are going to attempt another problem of computer organization. This question was asked in the year 2005. Marks allotted was 2 marks. So the problem statement is here. It goes like this. Consider a direct mapped cache of size 32 kilobyte with block size 32 bytes. The CPU generates 32-bit addresses. The number of bits needed for cache indexing and the number of tag bits are respectively, and there are 4 options. So if you see, a CPU address can be divided into several set of bits. The first set of bits can be called as block offset, and we are designating it with small b. Small b size of block offset part of CPU address in bits. With small c we are designating the next part of CPU address, that is cache index. In case of direct mapped caching, so we are here we are using direct mapped cache. So here after block offset we would be having cache index section, and the remaining bits would be the tag bits, and we are designating it with T. Let us use few more symbols. One is with capital B. Let us designate block size in bytes. Block size in bytes, and also use capital C to designate number of cache blocks. Now the formula to calculate small b is this. Small b is equals to log base 2 block size in bytes, that is capital B. And the formula to calculate small c is log base 2 capital C. The formula to calculate small t, that is number of tag bits, is equals to small a. Small a is the size of CPU address in bits. Small a minus small c minus small b. So with this formula we can get the answer. So let us put capital B, the value of capital B here in the formula to get this block offset size in bits. So here if you see, consider a direct map cache of size 32 kilobyte with block size 32 bytes. So here block size is 32 bytes, and if we put 32 in this formula, then we would get 5, right? So the block offset is of size 5. Now for cache index we need to know number of cache blocks. So here we are not directly given cache blocks, we are given the cache size. So cache size is 32 kilobyte, and we know block size, and block size is 32 bytes. So block size, that is capital B, is 32 bytes. Now if we divide cache size by block size, then we would get number of blocks in cache, or number of cache blocks. So number of cache blocks is, number of cache blocks here can be calculated by dividing the cache size, that is 32 kilobyte, by the block size in bytes, that is 32 bytes. So this would come out to be 2 to the power 10. How is it coming out to be 2 to the power 10? Let me explain it to you a bit. So 32 is nothing but 2 to the power 5, and 32 kilo is nothing but 2 to the power 10, right? So these many bytes, the numerator and in denominator we have 32 bytes, that is 2 to the power 5. I hope it is visible. So 2 to the power 5 and 2 to the power 5 gets cancelled out, and we have 2 to the power 10 remaining, and this is the answer. So the number of cache blocks is 2 to the power 10. Now if we put this value in this formula, so we have got number of cache blocks, and now we can put this into this formula, log base 2. In place of capital C we would put 2 to the power 10, and this is, if we take this this power out of the log, then we would get 10 log base 2 2, and that is nothing but log base 2 2 is equals to 1, that is nothing but 10. So small c is equals to 10, that means cache index size is 10 bits. Now the remaining bits, so this has come out to be 5 and this has come out to be 10. So the remaining bits would be the tag bits. So here the value of A is, that is the address size is 32 bits. So here small a is equals to 32, small c we have calculated to be 10, and small b we have calculated to be 5. So 32 minus 15 is 17. So here we have to choose the options from this 4 options given below. The correct option will have to choose. The number of bits needed for cache indexing and the number of tag bits are respectively. So the number of cache bits in cache for cache indexing is 10, and the number of tag bits are 17. So 10 and 17, this would be the correct answer. So thanks for watching. Bye.